Hi, in this video we are going to see about a Python IEEE project which is entitled as Heart Failure Prediction Using Machine Learning, which is an enhancement of IEEE base paper title Predicting the Classification of Heart Failure Patients Using Optimized Machine Learning Algorithms, which is an IEEE 2025 journal paper. Before seeing the execution of the project, let me brief about this project. So we all know that heart is one of the important organ for every human being, but due to change in food habits or other activities, so many people all over the world face the problem of heart disease or heart failure or cardiovascular disorders which are related to the heart and the blood vessels. So in this base paper, the authors have used the machine learning model for predicting the heart failure patients. So when it is predicted yearly, the need for this project is then the heart failure is predicted yearly when there is having high risk or low risk, so that the patients can be cured, so that they can come to know that there is some issue with them and they can get diagnosed accordingly. So in this base paper, the authors have used a data set which contains the dataset records of around 299 heart failure patients. So here they have used GPM model and they have achieved the accuracy around 94%. So here in the base paper, the authors have used the dataset with 299 dataset records and they have achieved the accuracy around 94% using their model, and these details have been mentioned in the base paper, but we are not going to do the same as mentioned in the base paper. So now let us see about our proposed system and what the enhancement that we have done from the existing base paper. So here in our proposed system, we have developed using two different models. The first model using the stacking classifier and second model using XGB classifier. So the first model using stacking classifier, we have achieved the train score of 99% and test score of 99%. And the second model XGB classifier, we have achieved the train score of 99% and test score of 99%. Now let us see about our proposed system. So here you can see the proposed title, Heart Failure Prediction Using Machine Learning, and this is the IEEE base paper title and the IEEE base paper abstract. Coming to our proposed project abstract, as mentioned, we are going to predict the heart failure prediction using machine learning. So we have developed this project using Python as the primary coding language, and we have used HTML, CSS and JavaScript for the front-end part, and for the web framework we have used Flask. So here in the dataset part, we have used 5,000 patient records with 12 distinct clinical features which include age, anemia, creatinine levels, diabetes status, ejection fraction level, high blood pressure, platelets count, serum sodium, sex, smoking habits, and follow-up times with the death event as the target variable. So here you can see that we have used a large data set when compared to the existing base paper one. And another thing, next we have used two different advanced machine learning model. One is using the stacking classifier and another using the XGB boost classifier. So as mentioned, both the classifier, stacking classifier and the XGB boost classifier achieved the training accuracy of 99% and test accuracy of 99%. So all these details have been mentioned in our proposed abstract part. Coming to the existing system, as mentioned, we are going to consider the base paper as the existing one. So in the base paper of the existing system, they are developed using an optimized machine learning approach for classification prediction of the heart failure patient outcomes. In the existing system, they employed mainly GBM, gradient boosting machine algorithm, optimized with the adaptive inertia weight particle swarm optimization AIWPSO method to predict whether the patient will survive to the heart failure or not. So the data set that they have used in the existing system contains 299 patient records with the 13 clinical features, whatever the mentioned features, the same like that. Then they have used the feature selection method using select k best and chi-square statistical methods they employed, and after that IEEE optimization algorithm was integrated with the GBM model to fine-tune the hyperparameters. So the existing method used the optimized GBM IEEE model significantly, and then they have achieved around 93.84, that is around 94% of accuracy. So all these details have been mentioned in the existing system of the project. Now coming to the disadvantages of the existing system, the main disadvantages of the existing system are limited data size, restricted feature diversity, dependence on single optimization algorithm, high computational complexity, class imbalance and synthetic data dependency, lack of real-time predictive capability, limited model interpretability, absence of web integration and user interface, lack of multi-model comparative deployment. So these are the main disadvantages of the existing system, which I explained detail about with the subheading of it in it. Next, coming to the proposed system. So as mentioned, the proposed system is an advanced intelligent framework for predicting the heart failure in the patient by utilizing the machine learning techniques integrated into a web-based platform. So in this project we have used Python, HTML, CSS, JavaScript and the Flask for the development of it. So here the proposed system employs 5,000 patient records with the various features in it, and then the dataset has been trained with the two powerful ensemble based algorithms, stacking classifier and the XGBoost classifier, and they have achieved the training accuracy of 99% and test accuracy of 99%. So the architecture of the system follows a modular design that integrates the data processing, model execution and the visualization. So the front end part will be uploading the data set and training the model, and they'll be entering the test data of the patient, and it will be predicting the result, whether it is a high risk or low risk for the heart failure, and the results can be exported in a PDF format, and they can able to see the performance analysis of the model and the graph part of it. So all these details have been explained detailedly, each and everything in the proposed system of the project. Next, coming to the advantages of the proposed system. So the main advantages of our proposed system are high predictive accuracy, large and comprehensive data utilization, integration of web-based interface, real-time data visualization, automated data pre-processing, flexibility and scalability, improving model interpretability, enhanced usability and accessibility, efficient performance evaluation, support for clinical decision making are the main advantages of our proposed system. So each subheading explain detail about the advantages of the proposed system in this. Next, let us see about the system architecture. This is the overall system architecture. Here the input is given as the heart failure clinical dataset records, and then it is pre-processed and made feature selection, and then it is sent to the stacking classifier and XGBoost classifier models, and the prediction result is shown as whether it is a low risk for heart failure or high risk of heart failure, and finally we show the performance analysis and the graphs of the project. So this is the overall system architecture of the project. Next, coming to the system requirement, these are all the minimum hardware requirements, and coming to the software requirement, this project can be executed in Windows 10 or 11. Coding language uses Python 3.12.0. Web framework is Flask. Frontend contains HTML, CSS and JavaScript. And this is the IEEE base paper reference. So now let us see the execution of the project. So just go into the source code folder. Inside that we have the heart failure folder. So inside that we have the app.py another file. So here in the address bar, let me type cmd and click enter. So the command prompt window open with the exact location of it. Now type python space app.py and click enter, and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome and paste it and click enter. So now you can see the project home screen, a welcome screen with the project title, heart failure prediction using machine learning. First click this login menu, it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click the login button. So now you can see the login success message and click OK. So now it will be navigated to the upload dataset part where you need to upload the clinical dataset. So just select the choose file option. Now go into the source code folder. Here we have the upload.csv. Just select this upload.csv and then select the upload dataset. So after uploading, it will be navigated to the preview part where you can preview the dataset that is uploaded. So this is the data set that we have uploaded. So I'll show you the data set in CSV format also. This is the original format which contains the features of age, anemia, creatine, diabetes, ejection, high blood pressure, platelets, serum, sex, smoking, time, death event. So here you can scroll down and see it contains around 5000 data set records. So this is being loaded here in this preview part. So you can scroll down till end on, you can see it. So you can scroll down until the end of the page. You can see click to train or test button. Just click it, and now you can see the training is in progress message. Now after some time you can see the training finish message and click OK. So now it will be navigated to the prediction part of the project where you can see you need to enter the features, and here you can see the option that select the model. Finally you can see, because we have developed using multi-model, so you can select whichever model you wanted. After entering the values of the patient, you can just select whether you wanted on the XGB boost or you wanted on stacking classifier. So after I will just show you with both the cases and let us see the prediction result. Now for the first case, I'll just enter the age as 55, anemia no, creatine phosphorine as 748, diabetes no, ejection fraction as 45%, high blood pressure no, platelets as 263,358.03, serum creatine as 1.3, serum sodium as 137, sex as male, smoking yes, and let us select the model as SG boost and let me click the predict button. So now it will be navigated to the result part where you can see the values that I have entered, and you can see the prediction result is low risk of heart failure, and you can also export the results in the PDF format. I'll just save it in the desktop. So you can just see heart failure prediction. You can see the values that we have entered, and you can see the prediction result. This is for the future reference of it. So now if you wanted to check for the other case, let us go for the prediction menu again. So now let me enter some other values and show you. Now for this case, I'm just giving age as 50, anemia no, creatine phosphorine as 318, diabetes no, ejection fraction 40%, high blood pressure no, platelets 216,000, serum creatine 2.3, serum sodium 131, sex as female, smoking no, select the model as stacking classifier, and let me click the predict button. So now you can see the prediction result is high risk of heart failure. So let me export the result. So you can just save it in the PDF format for the future reference. And let me show you with the case of the prediction part. I'll go to the prediction part and enter the details. Now for this case, I'm just giving these values, and now let me go to the predict button. So now you can see the predicted result is low risk of heart failure for this value. And let me go to the prediction menu. Finally, I'll show you the case. Now for the final case, I'll just give these values, and now I'll select the model as stacking classifier and predict. So now you can see the predicted result is high risk of heart failure. So in this way, you can check with the dataset value that is available in the test and train folder of the project dataset record with the various values, and you can see the results whether it is a high risk for heart failure or low risk for the heart failure using the various scenario cases in it. So now let us move to the next part, that is the performance analysis part. So in the performance analysis part, we'll be seeing the performance analysis of both the model XGB classifier and the stacking classifier. First, let us see the XGB classifier performance analysis showing the precision value recall and the F1 value. So precision value for the class low risk of heart failure 0.99, high risk for heart failure 0.99, recall with 0.99, and high risk for 0.99, both the F1 with 0.99 and 0.99. And here you can see the confusion matrix of the SGB classifier. It shows the true and predicted values of it. Next, coming to the performance analysis of the stacking classifier, which shows the precision, recall and the F1 values for both the classes low risk of heart failure with precision 1.00 and precision with a high risk of heart failure with 0.99, and recall with the low risk of heart failure with 0.99, and recall with the high risk of heart failure with 1.00, F1 with low risk of heart failure 0.99 and high risk of heart failure 0.9. And let us see the confusion matrix of the stacking classifier, which shows the true and predicted label of it. So in the performance analysis part, we have seen the both the models, performance analysis parameters, precision, recall, F1 and the confusion matrix. Finally, let us see the chart part. So in the chart part, we have various charts. So all these stats are static charts. This is based on the data set that used in the project and also the EDA process that is done in the model code. So let us see the first chart, that is the model accuracy comparison chart. This shows the model accuracy comparison of both the model XGB classifier and the stacking classifier, as all the values are same because both the models achieved the training accuracy of 99% and test accuracy of 99%. Stacking classifier also achieved the training accuracy of 99% and test accuracy of 99%. Next, let us see the patient age distribution chart. So here you can see the large number of patients with the age range of 60 to 70. Next, coming to the gender distribution chart, showing the gender distribution of female with 35% and male with 65%. And here you can see the comorbidity overview chart, which means that multiple disease. So the person having multiple disease, you can see anemia with 45%, patient 60% of diabetes, and high blood pressure with 70%. Next, death event distribution, showing the death as 32.1% and survive with 67.9%. And these are all the graph that is updated in the model, showing the death event versus count, time versus density, smoking count chart, and male and female count chart, serum sodium density chart, serum creatine versus density chart, platelet density chart, blood pressure versus count, diabetes count chart, anemia count chart. These are all the various charts that we have provided in the chart part of the project. So now let us log out. Before completion, let us see the frequently asked question for this project. The first question is, what is the main objective of this project? So the main objective of this project is to develop a machine learning based system which is capable for predicting the heart failure of the patient using the clinical data. So by analyzing the parameters like age, ejection fraction, serum creatine, blood pressure and other psychological indicators, our system should aim to provide the healthcare professional with the early detection of the patients, whether it is risk or low risk or high risk. Next question, which technologies are used to develop this project? So we have used Python for the main programming language, and HTML is JavaScript for the front end part, and Flask as the web framework. Next question, what type of dataset is used in the project? So we have used clinical dataset containing 5,000 patient dataset records, which shows the age, anemia, creatine, phosphorescent, diabetes, ejection fraction, high blood pressure, platelets, serum creatine, serum sodium, sex, smoking time, and the death event kinds of thing. Next, what machine learning algorithms are implemented? So here we have used two powerful machine learning models, stacking classifier and the XGBoost. So next question, what are the accuracy results achieved by the model? So we have achieved the training accuracy of 99% and test accuracy of 99% for both the stacking classifier model and the XGBoost classifier. Next question, how does the system work? So the systematic flow of the system work is like, first will be uploading the data set to train up the system, and then they will be entering the clinical record values of the patient, and will be predicting the values. The values can be exported in the PDF format for the future reference, and we can see the performance analysis part and the graph part of it. Next question, what are the key features of the system? So the key features of our proposed system is they can upload the data set, see the real-time prediction, performance visualization, and the model comparison kinds of thing. Next question, what is the role of Flask in this project? So here Flask acts as a middleware connecting the backend machine learning model with the front-end user interface. Next question, why was XGBoost chosen as one of the models? So XGBoost was selected due to its high efficiency, scalability, and strong predictive performance. Next question, what is the significance of using stacking classifier? So the stacking classifier combines multiple base models to improve the overall predictive capability. So instead of relying on single algorithm, it uses a meta model to integrate the strengths of the various classifier. Next question, how are the data visualizations used in this project? So here data visualizations are used in this project to make the analytical results more understandable and the informative to the user part. Next question, how does the system ensure data pre-processing and the quality? So before training the system performs various pre-processing steps, which include handling missing values, encoding categorical variables, scaling numerical features, and splitting data into training and set kinds of things. Next question, what metrics are used to evaluate the model performance? So here we have used accuracy, precision, recall, F1, and the confusion matrix for both the models. Next question, is the system useful for real-time prediction? Yes, the system supports real-time prediction. Next question, what makes this system different from the existing system? So the existing traditional diagnostic method heavily relied on manual analysis and the physician experience, which can be time consuming and subjective. So in the existing system also, the performance, the data set that they use was less number of data set records, and they have achieved the lesser accuracy percentage compared to the proposed system. Final question, how does this project contribute to the healthcare improvement? So this project contributes to the healthcare by providing the data-driven decision support tools that helps in early identification of the heart failure risk. By automating predictions and simplifying the data interpretation, it assists the medical practitioners in making faster decisions, and so that the patients can be treated according to the results that is predicted. So these are the frequently asked questions for this project, and this is all about the project heart failure prediction using machine learning. And thank you for watching.